For decades after the Apollo and Luna missions, the Moon held its secrets as humanity turned its gaze to other worlds. Then, seemingly overnight, the lunar race resumed. New SpaceX rockets took to the skies. NASA developed the Artemis program, and China quietly set out where no man had set foot. Rumors began to circulate about strange discoveries on the far side of the Moon. What exactly was found beneath the Moon's dust, and why is everyone returning? To start, let's provide some context. China's lunar program began relatively recently, in 2004, with an ambitious, phased plan. The China National Space Administration launched a series of Chang'e orbiters and landers, named after the Moon goddess, to systematically explore our closest celestial neighbor. Their goals combined science and strategy, contributing to China's rise as a space power. Chang'e 1, launched in 2007, was China's first lunar orbiter. It produced a three-dimensional map of the lunar surface and analyzed the composition of the soil. Most significantly, Chang'e 1's instruments detected traces of helium-3 in the regolith. This was the first hint of China's resource ambitions. A follow-up orbiter, Chang'e 2, was launched in 2010, carrying high-resolution cameras. It explored potential landing sites for future missions, flying just 15 kilometers above the surface to photograph landing zones and check the terrain for safety. 3 years later, China achieved its first soft landing on the Moon. The spacecraft touched down on the far side in a sea of rain and deployed the U-2 rover, which translates to Jade Rabbit. It was the first lunar landing since 1976. It ended decades of silence. U-2 traveled across the Gray Plains for the first time in history, delivering an ultraviolet telescope to the lunar surface, thus creating the first lunar observatory. In 2019, Chang'e 4, a mission that was destined to make history, was launched. It was originally conceived as a backup for Chang'e 3, but it was later repurposed for an expedition to the far side of the Moon. The goal was to become the first spacecraft ever to land there, an achievement that no other nation has ever achieved. China's methodical program demonstrated not only technological prowess, but also geopolitical ambition. The China National Space Administration, which is directly controlled by the military, pursued a dual goal: scientific discovery and strategic prestige. Some analysts believe that the main driver of China's interest is the pursuit of strategically important resources, effectively marking the beginning of a new energy race to the Moon. In other words, beyond national pride, the key motivation is the untouched riches of our satellite: metals, water, and nuclear fuel. So on January 3, 2019, the Chang'e 4 probe descended into the alien night of the far side of the Moon and made a soft landing in the von Karman crater. This crater is located within the colossal South Pole Aitken Basin, one of the largest impact structures in the solar system. The significance of the far side of the Moon is immense. It has always been turned away from Earth, hidden from our radio noise, and unexplored by previous missions. Scientists have long sought to explore its ancient terrain and pristine radio environment, but the technical difficulties have been immense. Because the Moon's thickness blocks direct communication with Earth, no probe has been able to transmit data without a relay. China has come up with an elegant solution: the special satellite Chang'e, translated as Magpie Bridge. In May 2018, Chang'e was placed at the Earth-less-Earth Lagrange point behind the Moon, so that it would have constant direct communication with both Earth and the far side of the Moon. This communications bridge was critically important. From the very beginning of Chang'e 4's descent above the surface, all landing commands were transmitted via Chang'e, and immediately after landing, the probe contacted the ground, precisely through this channel. However, the landing site remained in complete radio silence, an ideal environment for new experiments. Here, Chang'e 4 landed the U-2 lunar rover which translates as Jade Rabbit 2, which drove out onto the gray dust 12 hours after landing. This was a first in human history, and an impressive achievement, praised even by NASA Administrator Jim Bryden, and American scientists noted this success. On the reverse side, U2 took pictures of a landscape that no human being had ever seen up close before, a rugged plain under a black sky. The geology of the reverse side has interested researchers. It doesn't have the dark lava seas that dominate the visible side. Instead, the crust is covered in craters. By studying it, the probe could finally help answer the long-standing question of why the two sides of the moon are so different. Thus began a series of missions that have revealed, or rather sealed, a host of discoveries, from exotic materials to hints of resources that could fuel future colonies. But these discoveries are not only intriguing, they also answer many long-standing questions. And topping the list, of course, is the isotope helium-3, a treasure trove of lunar dust, and one of the moon's most talked-about resources. Helium-3 is rare on Earth, but it is abundant in lunar soil. It has been deposited there for centuries by the solar wind. In theory, helium-3 could power fusion reactors, providing clean energy on a vast scale. Chinese scientists are highlighting this potential. In 2020, a new mineral, Chang'e 5, was discovered among the samples returned by the Chang'e 5 mission, which interestingly contains traces of helium-3. Its appeal is striking. Just 41 helium-3 can provide as much energy as 5,000 tons of coal. Estimates suggest that the lunar regolith could contain over 1 million tons of helium-3, enough to power the Earth for thousands of years. It is no wonder that Chinese orbiters and rovers have been mapping the distribution of helium-3 and analyzing lunar soil since the very beginning. This valuable gas could well become the gold of the future lunar craze, and the Chang'e missions could be effective scouts exploring the most promising areas. However, not all discoveries were so predictable. In mid-2019, operators of the Uranus 2 rover noticed something unusual in one of the small craters, a shiny, textured area that stood out from the surrounding soil. The discovery of a mysterious gel has caused an internet storm. What could be sticky or liquid on the airless moon? Volcanic glass, molten meteorite, or something even stranger? Chinese officials initially refrained from releasing the photos, which only added fuel to the fire of speculation. But when the images were released, they showed a shiny, dark substance that had accumulated among the dust and rocks. Scientists who analyzed the spectrum of the substance identified it as breccia, soil and rock that had been fused together by the meteorite impact. In other words, a patch of glassy lunar rock, likely rich in minerals such as olivine and pyroxene, had melted and turned into a smooth mass. It's not alien slime, of course, but it's still a fascinating discovery. This substance resembled molten samples of Apollo regolith, but it was discovered in a completely new region. This shiny spot told of the high-energy collisions that shaped the moon's far side. Along with all this, amidst the gray wasteland, Chang'e 4 also carried a miniature biosphere experiment, a sealed bucket-sized container containing soil, seeds, and insect eggs. In January 2019, mission scientists reported sensational news. Cotton seeds have sprouted inside a container on the moon. This news was accompanied by a photograph of a delicate green shoot that sprouted under the influence of the moon's gravity. It was the first plant in human history to sprout on another celestial body, a symbolic look into the future towards interplanetary greenhouses. However, the plant did not live long. 2 weeks after landing, a lunar night set in, and the temperature inside the container dropped to -62 degrees Celsius. Without sunlight, and with the heaters turned off, the sprout died, as expected. But in those few days, it proved that terrestrial life could begin even in such distant and hostile conditions. Other seeds, potatoes, yeast, and fruit fly eggs were also placed in the biosphere in an attempt to create a miniature ecosystem. Although they did not germinate or hatch before the cold weather set in, the experiment was an important milestone in astrobiology. It demonstrated that astronauts might one day be able to grow food on the moon, a necessary step toward establishing long-term lunar bases. As one scientist put it, this is the first time that humanity has conducted a biological experiment with cultivation on the lunar surface. The tiny green leaf on the lifeless gray world has become a powerful symbol of future possibilities. News of China's further progress on the moon has quickly spread through scientific circles around the world, sparking a wave of hypotheses ranging from thorough discussions to wild conspiracy theories. In the West, many researchers have welcomed China's technical achievements and its relentless pursuit of data collection. NASA, although prohibited by U.S. law from officially cooperating with China, has nevertheless exchanged some lunar data and expressed its congratulations. Scientists have been eagerly awaiting the results of Chang'e 4's work in the field of lunar geology, and some have even begun to consider the potential for a third party to collaborate. The landing on the far side of the moon was hailed as an expansion of human knowledge about the moon. Could China gain an advantage in discovering resources or installing telescopes shielded from terrestrial radio interference? Such questions have fueled discussions at conferences and in political circles. At the same time, the secrecy of the mission and the natural mystery of the far side of the moon have given rise to less well-founded speculation. Theories about the language have flourished on internet forums and in tabloid headlines. Some speculated that Chang'e 4 had come across something truly spectacular, perhaps evidence of alien artifacts or ancient structures hidden from view. When the first reports of the gel-like substance emerged before any images were released, outside commentators began to speculate wildly, from living organisms to secret bases. Similarly, in 2021, the U2 rover spotted a cube-shaped silhouette on the horizon that was quickly dubbed a mysterious hut. For weeks, the internet was abuzz with jokes and theories that the rover had discovered a monolith or an alien hut. The rover team picked up on the joke, calling the object a mysterious hut, but made no extraordinary statements. As U2 approached over the course of several lunar days, the truth became apparent. The mound turned out to be just a strangely shaped rock lying on the edge of a crater. In fact, it resembled a sitting rabbit, which is fitting, since the name U2 translates as Jade Rabbit. Beyond the alien theme, there are more strategic and plausible theories. Observers have noted that the Chinese space program has military ties, raising concerns about possible hidden purposes on the other side. Some have suggested that the base there could be used to conceal activities, or even as an observation or missile launch detection post, protected from the influence of Earth. However, there is no evidence that Chang'e 4 carried anything other than scientific instruments. Its payload was openly published and even included contributions from Europe, including a neutron detector from Sweden and a radiation experiment from Germany. But the timing and focus of China's efforts, at a time when the United States and other countries are also returning to the moon, have fueled talk of a new space race. We now understand what has been discovered on the far side of the moon, and this discovery is changing the future plans not only for China, but for all spacefaring nations. The discoveries and lessons learned from the Chang'e missions have several important implications. First and foremost, it is the real possibility of establishing a lunar base. The success of the program paves the way for building a research base on the moon, perhaps on its far side. If humans set up camp there, they could take advantage of the unprecedented astronomical radio silence. This would allow them to listen to the universe without interference from Earth. But the far side of the moon also means permanent isolation and communications. Future bases will likely depend on relay satellites like Chang'e. China already plans to build a robotic research station this decade, perhaps using 3D printing to build structures from lunar soil. The far side is no longer out of reach, and we may one day see habitation modules or observatories built there in places permanently hidden from Earth's view. In addition, confirmed deposits of helium-3 and other minerals raise the prospect of mining on the moon. If helium-3 can be mined in significant quantities, it could revolutionize energy production on Earth. Chinese scientists estimate that 1 million tons of lunar helium-3 could meet the Earth's energy needs for 10,000 years, which could essentially solve global energy and climate problems. Although this is a rather speculative prediction and is unlikely to come true in the coming decades, the race for helium-3 has already become part of a geopolitical strategy. The country that first develops effective technologies for extracting helium-3 on the moon will gain a huge strategic advantage in energy. China's lunar missions are laying the groundwork for assessing the feasibility of extraction. In particular, the experiments have identified the optimal methods for heating lunar soil to release helium-3. The program is expected to be supported by organizations such as the Atomic Energy Administration. The moon could well become the Persian Gulf of the 20th century. Although the missions launched have landed far from the poles, their results are related to the broader search for water ice. In recent years, numerous missions, such as NASA's El-Cruz and India's Chandrayaan-1, have confirmed the presence of water in the moon's shadowed craters, especially near the poles. Water is of immense value. It can support astronauts and be split into hydrogen and oxygen for rocket fuel. The Chinese leadership has paid attention to this. In the coming years, new landers will be sent to the polar regions to assess ice deposits. Soil analysis data from the Chang'e 5 mission even showed the presence of hydroxyl, water bound in lunar minerals. And the presence of water and sunlight allows for energy generation, making the establishment of a lunar settlement much more realistic. China's program envisages the use of local lunar resources, meaning astronauts will be able to mine ice, melt it to obtain water, and convert it into breathable oxygen and hydrogen fuel. On the flip side, especially in the South Pole Aitken Basin region, ice reserves can be found in craters that are constantly in shadow. If so, the choice to explore this part of the moon could be justified by discovering the keys to sustainable habitation. As a result, the China National Space Administration has outlined a roadmap that sees the missions pave the way for an international research station on the moon with a crew in the 2030s. The idea is to build a base, presumably near the moon's south pole, in cooperation with other countries. However, one unresolved question remains: who owns the lunar resources? Currently, the 1967 Outer Space Treaty prohibits national claims to the moon. But as countries prepare to mine resources, new international agreements or conflicts may appear on the horizon. And it is already clear that the state that leads the search for and use of lunar materials will have a significant influence on the formation of these rules. The moon has become the central arena of the 20th century space race, and this race is unfolding in real time. After the launch of Chang'e 4, all key players have stepped up their lunar programs. China, for its part, continues a series of missions, building on its achievements. In 2020, a new generation of spacecraft returned samples from the visible side of the moon. In particular, the youngest lunar rocks ever found, about 2 billion years old. And in 2024, Chang'e 6 launched with the return of the first samples from the far side. It drilled into the surface and brought back about 2 kilometers of lunar soil. These samples are currently being analyzed and may shed light on the history of the moon and confirm previous measurements. 7th and 8th generation missions are planned in the future to explore the south polar regions of the Moon. Their goal is not only scientific discoveries, but also, perhaps, the beginning of infrastructure construction. For the lunar base, the Chang'e 7 mission aims to search for water ice and explore the polar environment, likely with a lander, rover, and even a small hopping probe to explore craters. Chang'e 8 will test technologies for in-situ resource utilization, and that mission could be the start of a permanent outpost. By the early 2030s, the People's Republic of China hopes to establish a core research station at the Moon's south pole, open to international partners willing to work outside the U.S.-led initiative. Meanwhile, the United States has revived its lunar ambitions through NASA's Artemis program, which is supported by private companies, including SpaceX and Blue Origin, as well as a coalition of allied nations. The goal of Artemis is to return American astronauts to the Moon and establish a permanent presence at the lunar South Pole. There is an unofficial finish line, the first manned landing of the new era. It was originally planned for 2020, the 4th year, but the Artemis 3 mission, which is supposed to deliver astronauts to the surface, has been postponed until 2025 and beyond. Realistically, the landing is not expected before 2027. China, for its part, has announced plans to send astronauts to the Moon by 2030, developing a new heavy-lift launch vehicle, the Chang'e 10, with a lunar shuttle. These schedules are extremely tight, and it cannot be denied that there is already a quiet competition. In 2024, Chinese officials first explicitly named the United States as a direct rival in the race to the Moon, a startling admission. The strategic report predicts that within the next 20 to 30 years, China's ILRS base and the United States' Artemis base will operate side by side on the Moon's south pole. The stage is already set in the same place, on illuminated ridges above dark craters filled with water ice. This is a region where both countries hope to plant their flags and build infrastructure. This is likely to lead to geopolitical tension. There are also concerns about territorial grabs, not in the usual sense of land, but strategically important locations. Both sides are eager to secure the best parts, those with constant sunlight for solar energy and located near ice deposits. The question of whose rules will govern this activity remains unanswered. This is no longer the cutthroat race of the 1960s, but a more complex mix of cooperation and competition. By law, NASA and the China National Space Administration cannot cooperate directly, but intermediaries, such as Europe, which has instruments on board Chang'e and is also a partner in Artemis, are creating a network of indirect interactions. Still, the general picture is clear. The space race is back. This time, the Moon is the prize for exploration and perhaps exploitation of resources. In the 1960s, the race to the Moon was a competition to get ahead of your opponent and leave a mark. In 2020, it is about securing a foothold for the future. The most important question may be, will these discoveries become an incentive for cooperation for the benefit of all humanity? Or will they, on the contrary, fuel the competition that will divide the lunar sphere? For now, the far side of the Moon is no longer left in darkness. It has become the testing ground of a new era, when states and even private companies are turning their eyes to the lunar surface as if it were the new Wild West. And in the meantime, the mysteries that could determine the future of our planet quietly wait on the silver ball above. Subscribe if you are interested in lunar exploration, lunar resources, space technology, manned missions, lunar bases, and the latest news from deep space.